On a cold February morning in 2016, Lower Manhattan was jolted awake by a sound so violent it stopped traffic. A $20 million, 565-foot crane had torn through Worth Street in less than 10 seconds, flattening cars and claiming a life in its path. This was no ordinary accident. It was the catastrophic collapse of a Liebherr LCR 1300SX, an engineering powerhouse built to reshape skylines. How could a machine designed for ultimate safety, armed with cutting-edge technology and strict wind limits, fail so completely in the heart of New York City? Beneath the twisted steel lies a hidden truth about missed warnings, split-second decisions, and the real cost paid when protocol breaks down. To understand how awe-inspiring design turned deadly, we have to begin with the crane itself and the growing threat no one stopped. Before steel ever buckled on Worth Street, the Liebherr LR 1300SX stood as a marvel of modern engineering. This wasn't just a crane, it was an industrial giant, purpose-built for the world's most demanding lifts. Its statistics are almost hard to grasp. A 330-ton maximum lifting capacity, a boom and jib stretching out to 565 feet. That's nearly as tall as the Washington Monument, rising from a set of crawler tracks that alone weigh more than a city bus. At its heart is a sophisticated control system. The operator sits in an insulated, climate-controlled cab surrounded by digital readouts, load angles, ground pressure, real-time wind speeds. The machine's load moment indicator, or LMY, acts as a digital brain, refusing to allow movement if any parameter strays outside safe limits. Modular counterweights, 124 tons at the rear, another 68 tons on the car body, anchor the entire structure, keeping the crane balanced even as it lifts loads that would flatten a lesser machine. Every component is designed to anticipate trouble. The high tensile steel lattice of the boom, the precision hydraulic systems, the fail-safes built into every movement. On paper, this is a machine that should never lose a fight with gravity. Its presence on a city street signals progress, precision, and above all, control. When a crane like this fails, it's not just a mechanical breakdown. It's the collapse of the very idea that human ingenuity can master the forces of nature. Forecasts for February 5th carried a clear warning: snow, dropping temperatures, and wind gusts reaching up to 30 miles per hour. The city's Department of Buildings issued an advisory the night before, reminding every crane operator of a strict rule. Crawler cranes must be secured when sustained winds are expected to hit 20 miles per hour. On Worth Street, the crew finished their shift as usual, but the crane remained in its working position, elevated and exposed. The overnight lull gave a false sense of security, even as weather models predicted a turbulent morning ahead. By dawn, the wind was already stirring. Gusts rattled scaffolding and sent plastic sheeting flapping against building facades. The site manager reviewed the forecast, aware of the city's threshold and the manufacturer's own cautions. Still, the decision was made to proceed with lowering the boom rather than fully stowing the crane the night before. The operator, relying on real-time wind readouts, watched as the numbers crept closer to the limit. The plan was to bring the boom down to a safer angle, but each degree of lowering increased the surface area exposed to the wind, a fact well known to veteran crews, yet too often underestimated in the rush of a busy city job. The boom and luffing jib, now stretched out like a steel sail, caught the rising gusts. The operator's hands hovered over the controls, eyes flicking between the wind gauge and the street below. Every decision in those moments balanced risk and routine, protocol and pressure. As the wind pressed harder, the gap between safe operation and disaster narrowed to a razor's edge. Wind is invisible, but for a crane operator, it is a force that can be felt in every vibration of steel. On Worth Street, as the boom began its slow descent, physics took the controls. Lowering the main boom to about 72 degrees was supposed to make the machine safer, but it also exposed hundreds of feet of latticework to the morning gusts. The longer and lower the boom, the more it acted like a sail, a giant lever amplifying every push from the wind. Counterweights, all 192 tons of them, were stacked at the rear and along the car body, engineered to keep the center of gravity firmly inside the tracks. But the physics of tipping are ruthless. As wind pressed broadside against the boom and luffing jib, it created what engineers call an overturning moment. The force tried to rotate the entire structure around its tracks, shifting the center of gravity closer and closer to the edge of stability. The operator's hands tightened on the controls, eyes flicking from digital wind gauges to the skyline outside. Each gust sent a ripple through the steel, and the machine began to sway. A warning sign no veteran ignores. The LMY, the crane's digital brain, was designed to halt movement if limits were breached. But wind is not a steady number. It surges in unpredictable bursts. In those final seconds, a sharp gust hit. The combined force of wind and the immense surface area overwhelmed the counterweights. The balance was lost. The center of gravity slipped past the tipping point. In less than 10 seconds, the fate of the crane and everything below it was sealed. Worth Street, once a busy artery in Lower Manhattan, became unrecognizable in seconds. The collapsed crane stretched nearly 2 full blocks, its tangled latticework blocking the road from curb to curb. Steel twisted around crushed cars, some flattened to the axles, others pinned beneath tons of wreckage. Glass blanketed the pavement, shimmering among chunks of concrete torn from the sidewalk. Storefronts and historic facades bore deep scars, shattered windows, broken cornices, and gouged brickwork from the impact. 4 buildings, including offices and shops, were damaged badly enough to require temporary evacuation. Emergency crews picked their way through a maze of debris. Utility crews scrambled to shut off gas and water mains already leaking from ruptured pipes beneath the wreckage. The boom's immense weight had cracked the street itself, exposing tangled wires and fiber optic cables. For hours, alarms echoed off the stone and steel, while the air filled with a haze of dust, snow, and the sharp smell of diesel fuel. Pedestrians who had been blocks away described a sound like an earthquake, followed by silence, then chaos. Residents rushed outside to find their neighborhood transformed into a disaster zone. In that instant, the collapse was no longer just a mechanical failure. It was a crisis that touched everyone in the area, with ripples that would last far beyond the morning's destruction. The collapse did more than twist steel and shatter glass. It changed lives forever. David Wicks, a mathematician on his way to work, was killed instantly when the crane struck his car. 3 others were injured, 2 seriously, as tons of metal tore across the sidewalk. For days, Worth Street was sealed off while emergency crews and salvage teams worked through the wreckage. The cleanup was painstaking. Every section of the crane had to be cut apart and hauled away, all while avoiding ruptured gas and water lines beneath the street. Businesses shuttered, residents displaced, and legal battles began to unfold. When the final bill was tallied, the damages soared past $20 million, a sum that could never account for the loss felt by a single family or a shaken city. In the aftermath, city officials faced a hard reality. The existing safety net wasn't strong enough. Within weeks, New York's Department of Buildings rewrote the rulebook for crawler cranes. The wind speed threshold for mandatory shutdown dropped to 20 miles per hour, a number now hard-coded into every operator's daily routine. But policy alone wasn't enough. The city also mandated digital anemometers, precision wind monitors, on every major crane. These devices record wind speed in real time and stream the data directly to city inspectors, removing guesswork from the equation. Enforcement moved from periodic checks to continuous oversight, with violations triggering immediate penalties. The new standards don't just react to the past, they anticipate the next storm, turning every crane into a node in a citywide safety network. For crews on the ground, safety is no longer a matter of interpretation. It's a matter of record. On February 5, 2016, a 565-foot crawler crane collapsed in Lower Manhattan, killing David Wicks and causing over $20 million in damages. Investigators determined the crane itself did not fail mechanically. Instead, the collapse was triggered by wind gusts exceeding city limits and lapses in safety protocols. The crew's decision to lower the boom during high winds created additional risk, as confirmed by Department of Buildings reports. While the precise sequence of every operator action remains under review, official documents show the city responded by lowering wind thresholds for crane operations from 30 to 20 miles per hour and requiring digital wind monitors on all large cranes. Today, these rules aim to prevent similar disasters, but the Worth Street collapse serves as a documented reminder. Even advanced engineering demands unwavering adherence to safety. The lessons written into New York's regulations stand as evidence that progress often follows tragedy.